Hello, my name is Tomasz Relek and I will guide you through the Java Frameworks Compare project in the DataStax examples repository. Let's see what we will learn in this video. Firstly, we'll set up the project that is available under the provided GitHub link. Next, we'll connect various Java frameworks such as Spring, Micronaut, Quarkus and Helidon to DataStax Astra Cloud. Finally, when everything is up and running, we'll make a performance comparison of the compile time, startup time and memory usage of these frameworks. Let's start by cloning the project using git clone at DataStax examples Java Framework Compare. Once we downloaded the project, please open it in the IDE. We will be using the DataStax Astra Cloud, so please make sure you have the instance up and running. I have the Frameworks Compare instance already up and running. This instance should have created keyspace with the name keyspace1. The username and password should be DataStax to make things easy. If you don't have the instance running yet, just open the dashboard tab and click the Add Database. You should be able to start one free instance. The Frameworks Compare project will use issue table. We need to create this table before running measurements. We can use the Astra Studio to achieve it. Let's open the Studio, view and create a new notebook. In the notebook, we can create an issue table using create table if not exists, issue, ID, UID primary key, name text, description text. Once it's ready, just click Run and we can see that query succeeded. Our DataStax examples will be using Astra as a database. To be able to connect to it, please click on the Connect button. It will open a new view. In this new view, please check the connection method to the driver. It will allow you to download the Secure Connect bundle. We'll use this bundle to connect to Astra from various Java frameworks. Please copy the full path where the Secure bundle is downloaded. We will use this information in the next step. The Frameworks Compare project is using Astra. To allow those frameworks to see the Secure bundle, we need to set the Astra DB bundle environment variable to a location where we downloaded it. I'm setting it in my command line, export Astra DB bundle and the absolute path to the Secure Connect bundle. This project has a couple more prerequisites if you want to run all examples. Firstly, you need to have JMeter installed. JMeter is a Java tool used for performance testing. We'll use JMeter to simulate a load to test memory consumption of frameworks. If you are on Mac OS, you can just do brew install JMeter, otherwise please visit the JMeter website and follow the installation steps. All frameworks examples are written in Java programming language, so I assume that you have JDK installed. It should be in at least version 1.8. To allow proper isolation of tests, we are using Docker to run every example. Frameworks are packaged into a Docker container. Next, the measure.sh script is starting those containers one after another. I assume that you have Docker installed. One of the examples is using GraalVM. GraalVM is a high-performance environment that should have the best performance. If you want to run this example, please install the GraalVM following those steps. Let's take a brief look at one of frameworks code. We'll look at a Spring code because it is one of the most commonly used in the Java ecosystem. In the application.properties, you will find the keyspace configuration that should match the config from Astra UI. The username and password should also match the values from the Astra database. The Secure Connect bundle points to the var directory that is available within the Docker container. The Docker compose YAML script that prepares the Docker environment uses the Astra DB bundle that we set a couple of steps back. It picks the bundle and put it in a Docker image using volumes. Thanks to that, the Astra Secure bundle is available within a container. Every application has its own Docker image. It is exposing the REST API on the port 8080. Let's take a look at the issue controller. It exposes a variety of REST endpoints for interacting with the issues database. We have the read method for getting the resource. There is also a create method that posts a new issue. There are also put, post, and delete REST API methods. If you look at other frameworks, you will notice that each of them exposes the same REST API. This is essential because it allows the measure.sh script to run the same performance tests for all frameworks. Finally, we can run the measure.sh script to build Docker images for each framework. Next, it will start testing of startup and compile times for all frameworks. Please note that every step is running 5 times to have more repeatable results. If you want to have faster feedback, you may reduce it to 1 run. The whole procedure takes a long time, but I have some calculations already. I collected them before this presentation to not lose time waiting for them. Let's start with compile time results. Please note that you may observe different compile times depending on your environment, but the overall trend should be similar. The compile times are very similar between frameworks. Only the Quarkus Graal is 30 times longer than any other framework. This is expected because Graal is compiling everything upfront using ahead of time compilation. On the other hand, other examples are using standard JIT compiler that will kick in at the runtime. Therefore, the compilation is postponed to later times. Graal tries to compile everything upfront to reduce this overhead at the runtime. The startup times are reflecting that. The Quarkus Graal startup time is almost 3 times faster than Spring Data. Other frameworks look similar. The Micronaut is a bit faster than Spring, Helidon, and Quarkus without Graal. Let's switch now to memory usage. Firstly, the measure.sh script is examining the memory usage at the startup. The Quarkus is very optimized regarding memory usage. The memory consumption of Quarkus Graal is 3 times less than the Spring Data. Surprisingly, Quarkus without Graal is also very memory efficient. Finally, the measure script is using JMX to simulate the load. It uses 50 concurrent users and interacts with the REST API of all frameworks. Those results seem most important because they are showing the real resources consumption during load. Quarkus on Graal VM and also Quarkus shines here. The memory consumption while serving the same traffic is substantially lower compared to other frameworks. If after performance testing you want to try Quarkus on your application that uses Cassandra, you may check out our Cassandra Quarkus extension that simplifies building a Quarkus application with Cassandra. This is all from my side. Thank you for watching this presentation. If you have any feedback regarding this presentation or project, feel free to share it with us.